Okay, I think that we can start. I can see some faces that are saying to me, I'm dreaming a beer, and I'm doing that too. It means that okay, it's gone. Bye. it means that I'm not going to take you a lot of time. We already spoke together before. We know each other already. But yeah, if you was not on my presentation before, I'm Gianluca Arbezzano, and I'm kind of I like Twitter and I follow people and what they said. That one is my handler. If you have some question or you're just happy to hear what I'm saying more than 1 hour, you can follow me there. I work as a site reliability engineer in InfluxData. InfluxData is the company that run InfluxDB, is the time series, open source time series database, and some other projects. If you don't know about them, just have a look, because it's open source. You can try and see how it goes. But I'm not here to speak about time series, not yet anymore. I'm here to speak about Docker security. And I'm here to speak about this because weeks ago, I released a free ebook that is called Play Safe. You can see the link is over there, scaledocker.com. And I just put together the presentation on top of that PDF, because I really enjoyed writing dev chapters, and okay, let's say I enjoyed it. Let's try to make a presentation. And well, that's my first try. Yeah, the idea is that what I learned from Docker and using Docker, because a lot of stuff that I'm sharing today come from my experience as contributor and maintainer in the Docker community. And security is something that needs to be easy to use. It's like the pipeline that we spoke before. It can be really complicated and sophisticated, but it needs to be easy to use from the end user, because otherwise you are going to have trouble, because the user, your colleagues that are using your kind of security feature, if it's something that needs to be able with complex tags or something like that, they are just going to disable it and not using. If you are designing a tool and you are thinking about security, you need to put it really, really simple. And if you can, security by default is something that can happen. What we mean with security by default is something that you cannot disable. You cannot take a decision, well, today I'm running Docker Swarm not secure, in a not secure way, because it's secure by default. There are some features security-oriented that you cannot disable. I'm going to speak about them later. But this is like a slide about everything that you do about security. Think about security as something that can stay always enabled. It's kind of a different mindset for what we learned from previous projects, because pretty much all of them has some certificate or some security feature that are hard to use in development, and you need to disable them and enable them in production. That's something that Docker is trying to leave as mindset. Another big topic is least privileged. How can you make secure something that it's not running? What is not running is super secure. Code that doesn't exist is bug-free and super secure. That's the idea. If you don't need a kernel package or a kernel module, or if you don't need a dependency in your Linux or in your container or in your application, why are you installing that dependency? Well, it was already there because Ubuntu has a lot of packages and CentOS has other packages, and I just have that dependency. I don't know what to do. Well, less privileged is remove everything that is not used, remove everything that is not necessary. You are going to have a double win, not just from security point of view, but also from the size of your project. Your site is going to have less code, it's going to be easy to maintain. That's the idea. What there isn't cannot be break. There are two kinds of security that I have in my mind. One is the runtime security, and for runtime is what is checking live what's happening. Let's say that you are checking the traffic that is coming through your application runtime. It's something that happened. It's not something that you are making before or after. It's something that is live with your application. And I'm going to speak about tools like AppArmor or Seccom or Linux that are provided by Linux and that you can use to make secure your container. Other kind of security tools that we are going to see during my presentation are static. It means that you need to run them before or after to check if your images, in this case, is compliant. Image scan and CoreOS Clair are tools to scan your containers. Every time that you build your images, you need to understand if it's compliant, if it's secure, if all the packages that you are using are safe and there are no vulnerability into the container. There are different kinds of tools, and we are going to see some of them. Another vulnerability that another kind of security is during the update. It's really something that you need to think about because it's a problem that you already have in your system right now. Every time that you update your code, you are changing the state of your application and the state of your environment. The new code where it comes from, it usually comes from an external repository, or it can be GitHub, or it can be a Docker registry, it can be a Ubuntu packages, or Gem, or whatever, Maven repository. It's something that from outside comes to your server, and who knows where it comes from and what it contains. That's a problem. Another, this is what I usually share because I think that changed the mindset. We have a lot of services that are running, Jenkins, Logstash, and monitoring, time series database, normal database, SQL, NoSQL, anything is running and is exposing a port. But from the outside network, from the outside, what matters usually is that you have a public port 80 and a public port 433 for SSL. Everything else can stay behind a VPN, behind a firewall, behind everything you want, but the unique public entry point from your application usually are 80 and 433. Anything else can be secured by network. You can use a VPN. I saw and I worked with a lot of startups that was not using a VPN because they was thinking, oh, it's so expensive to use. I don't know how to configure it and maintain. What happened when the VPN go down? I don't know what to do. It's not that complicated anymore. OpenVPN is well, affordable. You can install it and configure it properly and understand how it works and manage it without becoming crazy. And it's going to have a huge impact from your security. Because in practice, when you are connected to the VPN, your laptop is bringing into the data center, and you are in the kind of private network of your data center, or a sub network, like it depends on your configuration. But the idea is that you can really expose port 80 and 43 from a pool of servers, and everything else is behind that. And we are working as DevOps, and we know how many tools we are installing and how many of them are exposing ports. It's really hard to keep track of them. Probably the real good solution is just, okay, let's expose port 80 from these 10 servers that are my front ends, and everything else is behind the VPN. That's also for testing is like a good solution because you don't need to keep in your mind what you have exposed or not. Port 80 and 43. Anything else is behind the VPN. The first tool that I'm happy to share is Linux. And it's a kernel module and a library that is installed in your kernel. You just need to enable it. It's distributed in the most common operating system. And the idea is that by default, everything in your system has a label. Files, everything is a file, but a file has label. And you can create policy on top of this file. And you can say, I don't know, you cannot write this file, or you cannot read this socket. And you can attach all this policy to your running container. Docker supports Linux policy. It means that when you start a container, you can specify the proper Linux policy, and you can close your container with that policy. Another similar tool is called AppArmor. They are kind of doing the same stuff. Cilium maybe is a little bit more flexible and stable and old, let's say old. And AppArmor is younger and it's created because C Linux is really hard to have running. The policy in C Linux are really complicated. And in AppArmor they are complicated too, but less complicated for what they say. And this is an example of policy. You have the name of the policy, and in my example, I deny writing on that specific path. It means that my container is not able to write on a etcd directory. It's simple because if you it's simple to use. AppArmor is a daemon. You can load your policy inside that daemon, and when you run a container, you can attach security ops, and AppArmor sample on is the name of the policy. And your container starts with that policy. That's like a summary. I wrote that we are denying writing on the etcd directory, and I can write a new file on the temporary directory, but I cannot write in etc because the kernel is stopping me because I have no permission to do that. That's the idea. You can make your AppArmor configuration really sophisticated and depend of like your use case and how much you know the application that you are running. Jess Frazel is she helped Mesosphere to write the container security, and after that she joined Docker, and now she's working in Google, always in kind of the security area, and she wrote this to it, and I just I just quote her. It's not easy to write and maintain AppArmor configuration policy file. She wrote a nice CLI tool that is called Bane that you can use to, generate policy in a maybe easy way. All these kind of tools are really easy to use if you know what you are doing. If you run one application in every container, it's a best practice. I hope that everyone knows that this is maybe the first best practice that you need to have in your mind when you run a container. If you're running more than one process inside the same container, like Apache and MySQL, you are doing something wrong. You need to split process between containers, because you can make more tuning around your container itself, because you know what it's running, you know that it's exposing one port, that it needs to write in that kind of directory, and you know that MySQL is probably going to use that amount of memory and that amount of CPU, and you can use cgroup to limit the resources for a specific container. If you start to run more than one process, different process in the same Docker container, this kind of tooling is not that easy as it can be with a single process. You also need to know what you're running, and that's not always easy for us that we are running so fast. We are so happy to try new tools everywhere, and it's not easy. Like we need to make some research and understand where that file, where that application is writing, where is reading for, what it expects, which port is using dependency and stuff like that. Sometimes it's also hard to know if the application for the application that we are writing, because maybe it's so big and so old that we don't know what it's doing and where it's writing. But that's the main concern that I have. If you're doing to close your container in a real gel with AppArmor and all these kind of tools, we need to know what you're running. Another tool, runtime tool that I really like is Cilium. You can think about it as the next generation of IP tables. When all the containers come to us, we rethink a lot of stuff. We think about how we deploy, how we schedule virtual machine and containers, where we store snapshots and images, how we save files in this kind of dynamic environment where everything change. What about networking? And what about firewalling? And Cilium is this kind of tool. He's cross vendors. It works with Kubernetes and Docker, and the idea is it's using BPF, that is bytecode that you can inject in your kernel, and it's going to read all the traffic in your network, and you can say, okay, this container is able to communicate with this one, this set of containers can speak with this one, and that's it. The problem, is trying to solving the problem that have the overlay network. When you work with Docker and you have your overlay network, you can put all the container in the overlay network, and if they are in the same network, they can reach each other. The real problem is that if you put together MySQL and your Go application that are, because the Go application need to speak with MySQL, the overlay network is allowing you to do that, but it's also allowing you to do the opposite, because now your MySQL can speak with Go. And if you think about the least privileged kind of mindset, MySQL doesn't need to speak with the PHP application, the Go application, PHP application. It's monodirectional. And that's what you can say. It's based. That's what you can do with Cilium. It's based on label, it's well integrated in Docker. You need to create a new. It's a daemon that you install in your server, and it has also integration with Docker. It has a networking plugin that allow you to create a new kind of network. In this case, I'm creating a network called Cilium that use the driver Cilium. You can say that I'm not using the driver overlay because I'm using the new capability provided by Cilium. Now that I have the network, I can run containers inside that network. You can see that I'm running a container called server in the Cilium network, and I'm adding label because it works on label. In this case, IO Cilium service.server is the first one. I'm using another label, and I'm running another container, the client. What I'm trying to do is simulate a normal connection between a client and the server. I have two containers with two different labels in the same network. It means that they are good enough to speak with each other because they are together. This is the same. And at this point, Cilium is not just a daemon, but it also provides CLI with some commands. With Cilium endpoint list, you can see all the labels that Cilium discover in your system. In our example, the two labels that we attached to our container. And if you try to ping server from the client, you will see that it's not possible because Cilium is already stopping you. And what you can do at this point, you can probably, if you think about this kind of problem when two containers are not able to speak with each other and you don't know what to do, at some point you come with TCP dump and you are tracing the code between servers and you try to understand what's not working. What you can do with Cilium is using Cilium monitor, that it's starting a CLI monitor that is showing you what's happening in your server. In this case, what you can also specify, you can ask to Cilium if the status of the label with this command Cilium policy allowed. I'm asking to Cilium if the source Cilium service client is able to speak with the destination. The option D is the destination. And what Cilium says is that the policy is denied. I cannot speak with that label. It means that we have already a strange behavior because two containers in the same network are not able to speak with each other. What's going on here? And that's Cilium that is telling us you can't because you didn't specify nothing different. I just put here a short example, but you can write policy too. The policy are JSON. And the idea is that you can like create your policy. And in this case, I'm saying that the label is a nesting. If you remember, I call it io.cilium.server. And I'm already in the server child here. And I'm saying that the rule for the server is to accept connection from the client here. And that's what you can say. You can take the label that you attach to your container, and you can create policy on them and say, OK, client is able to speak with server, but not the opposite. And you can, like, it works like normal. It's a daemon. It means that you need to load your policy. And when your policy is loaded, it starts to accept communication between your container again. It's a really powerful tool, and it uses another really powerful tool behind him that is BPF. BPF is a highly flexible and feature virtual machine-like construct in the Linux kernel. And what it's doing is like scanning, networking, and tracing kernel calls. You can also do this kind of stuff on kernel calls, and you can filter and block and persist action if you need to do something. And the good part is that you don't need to recompile the kernel because the binary is injected into the kernel itself, and you don't need to recompile the kernel. That is usually not really good to do, not really easy to do. And yeah, you can, like, BPF, it's getting more used and used on different environment. One of them is the kind of networking security purpose. Another one is for monitoring, because you can scan your, you can write an agent that is able to scan network traffic, and you can detect which service are running. And for example, your agent can be able to auto-detect what is running inside the network, just be inside. That's why BPF is important and can be used as security tool by default. You just need to write something. Another set of concerns that I have for you are about images. We have this kind of concept, and I think that everyone here knows what an image is. When you run a container, you are using an image as base started point, and they are made of layers, and every layer is like over another, and they are squashed together when a container starts. And the idea that the main goal for an image is to be small enough to be pushed in a registry and pulled without too many. You need to be small to don't need to expense. Yeah, it can be a real expense pull an image. This is a graph that Docker provides to understand the scale. You can see all the projects that they released in time, and all the Docker pull that somebody did from the registry. It's crazy that in 1 year they just doubled billions of pull that they made. It's like it's a big number. But the idea is that we are continuously pulling and pushing images. Doesn't matter in Docker Hub or in our private repository, but it's something that we do every time because Docker is helping us to ship code between containers, and this code needs to be in some place. Image need to be small, not just for the from a size point of view, but also because everything that you are not using in your images can be a vulnerability, can contain a vulnerability. It means that you can start your container from Debian, but maybe it seems so big. Like Debian is really big, my application is so small that I don't need Debian. I can use Scratch. Because I'm a cool Go developer, I come with a binary that can run everywhere, and Scratch is the little image that we can use. It's just nothing. You just add your binary and you run your binary. Yes, it's really good, but when you have a problem in production and you cannot exec anything inside a container, it's not good. Like if you don't think about this point when you have a too small image, it's a security problem, maybe. You need to think about that every time that something bad happens, you need to have tools to debug. And Scratch is probably not the right one because you have nothing. Maybe you can use CentOS, but I don't know. I don't know how YAM works, and I don't know. I don't like it. You need to come with your solution. I don't have the solution for you because every kind of team and every people loves different distribution. You can use Alpine if you like the small one. You can use pretty much every distribution has a kind of image, a small image. For example, Debian has a image tagged as SED. That is the small version of Debian. It's on top of you, and the idea is that you just need to keep in your mind that if it's too big, you are using a lot of bandwidth, and you are maybe going in some vulnerability. Yes, library, sites, and security. Another one is debugging. As I said before, you need to take care about what you can do during a disaster. And usually during a disaster, you don't care that much about the size of your image at that point. If nothing is working, you maybe are going to use really bad words against that container. You need to maybe take care about this before that happens. What you can do is use Linux Kit or something like this to build your own little kernel and little distribution. It's really hard at the moment because there are not really big kind of philosophy and use case around this. Linux Kit is a project that Docker released during the DockerCon 2 months ago, maybe. And the idea is that you can build your kernel from a specification file, and you can have your little kernel to run everywhere you want. As I said before, it's probably going to be something that we will do between 2 or 3 years. I really don't know. What I know now is that manage your own Linux distribution is not that easy. You need to have good knowledge, and you need to have teams and people able to achieve this kind of goal. But maybe it's something that you can have a look. And it's a really good project, and it's continuously growing right now. There are a lot of contributors from different companies. It's definitely something that you can have a look on. We spoke about images, and another idea is that every time that you build your image, you can scan it and looking for vulnerability. In the same way that you did with Linux kernel, you can scan and look for vulnerabilities of all the package that you have inside. For example, if you have OpenSSL installed and it's an old version, maybe you have the heartbeat vulnerability still there around, and you need to update it. How keep tracking of all this vulnerability? You can use Docker Scan. It's has a service project that Docker sell in Docker Hub. All the official images are scanned by default, but your private images and your public images are not scanned. You can buy and scan them. The idea is that every images and every tag in your images will be checked, and if there are vulnerability, it's going to show you which one of them, and you can solve them updating and patching your kernel and your image. There is another project that is called Clair that is provided by CoreOS. CoreOS is the other big player around containers. And in practice, what Clair does is a security scan open source. You have your repository, you attach your repository, and it's going to check if your image is compliant. Every time that you make a build, it's going to check if there are new vulnerability, and it's notifying you about which one of them are affecting your images. You can also, it provides a easy way to rescan all the images, because the idea is that maybe somebody is going to find a vulnerability after that your Docker image is built, and how do you know that your old image is affected? You don't know that. Clair has a system to sync with the security vulnerability repositories, the most common. You can add them in the server, and it's going to scan it. If you cannot use the as a service product provided by Docker, you can install it, and it's available. It's used. This is for later. It's used behind the Quay, that is the registry provided by CoreOS. I don't know if you, there is another big Docker hub that is not by Docker, but it's by CoreOS, and it's called Quay. And it's using Clair to make security vulnerability. It means that you have also a big use case in terms of scaling, because there are thousands of images. Yeah, that's it. Like we are secure. Our images are secure. Our runtime is secure. What can possibly go wrong now? As I said before, one of the important points when we think about security is the update. The update is important because it can be a problem. You are injecting new code in your system. Sometimes it's your code, and that's a big problem if you're injecting your code in a system. Other time can be some other vendors that are releasing a new package and you are just downloading it as dependency. Or maybe you are updating CentOS or Ubuntu and there are new packages. You are installing stuff from Ubuntu repository. You don't know what are you doing. And all this stuff can change the status of your system. What Docker is using is called Docker Content Trust. And you can enable it in your CLI via environment variable. And the idea is that everything that you do around pull and push and build is made secure. I call this feature everything that stay behind the pull, because before listen to a guy that was implementing this feature, I was not aware about all the stuff that happened when you do Docker pull and Docker push. I'm happy to share some of them with you today. The problem is how we usually check what there is inside a file. We usually use SHA to compare between content. If the SHA of two files are the same, there is the same content. That's the idea. We signed up with GPG and we use TLS to ship all our files. But there are some questions that we still need to answer. In first, we have a problem. SHA-1, Google just created the first collision between SHA-1. It means that they are able to create one file, two different files with the same SHA. That's unsafe at this point, use SHA-1. You need to use another kind of encryption algorithm. And there are some GPG limitations. Because if you think about what you are doing, like where my registry is and my package, that the image that I'm downloading is coming from the package that I hope is really coming from Docker Hub, or there is something in the middle that is like changing traffic and I'm downloading something else. There is something between the sender and the receiver. I don't know. Are the signatures too old, or the people that sign that package are allowed to sign that package, or that sign is a fake? There are a lot of kind of questions that you can try to solve with JPG and TLS, but it's not that easy. You need a complex framework around it. And we have a complex framework around update. It's called the update framework, clear. And you can find information about this project in GitHub, the updateframework.github.io. It's a paper. It's a university paper. It's really complex, and it's a really good read if you have some free time. The idea is, how are we going to answer all these questions? How are we going to understand where our package comes from and what it contains? The good part is is that it's a framework. It means that Docker has one implementation and is using that behind the pull and push, but there is a specification that you can take and apply. The idea is that we are going to distribute software more often and in really different kind of place. Because if you think about all the IoT stuff that we are building, or our car, that's a problem. Like how we are going to update as a software and some code that is running in a car. We need to reach the car. The car it's in a public network. Everything can happen between my update server and the car. We need to, it's a problem that we are going to have. The framework is inspired by the Tandy, that is the Tor secure updating system. Tor is the browser, the secure browser and anonymous browser, and they have a server to update itself, and it's inspiring the Tuff framework. who is using the Tuff framework is not just Docker, but CoreOS is also using the Tuff framework. The main principles about the framework are responsibility separation, and the idea is that you have a set of, it's based on keys. It means that you have a lot of keys for different kind of scope, and this scope are designed to be like replaced. It means that if a key is not valid anymore because you discover that you lost your key printed in a Starbucks and you need to regenerate your key, you can regenerate a specific role of the key. You don't need to regenerate all the keys that you used. As I said, it's survivable by key compromission and is multi-signature thresholding. It means that you can say my package needs to be signed from 4 users to be valid. And when your client downloads that package, it checks if there are 3 signatures and that if the 3 signatures are valid. If they are invalid, the download didn't start. It's not starting. Tuff is the update framework. It doesn't manage your signature. It means that it's your packages, but it manages your signatures. It means that there is a completely separate repository where all the signatures and all your images, the SHA of your images are stored with all the people that signed the package. And the client is not just going to ask the Docker Hub to get the image, but is also verifying that all the signatures are good. It means that your file can be whenever they are now. You just need to sign them in some way with that framework. As I said before, there are different rules involved. One is the root rule, and every rule has a key. The root rule is the main one. It's the father of all the keys. And it has usually a really long expiration time because it's hard. Because when you change that key, you need to resign all the packages. It means that usually it's the oldest expiration date that you have is like 5 years, let's say. Target, snapshot, timestamp, and delegation are other rules that you can use. For example, snapshot is target is checking that your package usually is checking that your package is the package that you're looking for. The snapshot is more concerned about versioning. It means that every tag is signed with the snapshot, and every time that you release a new tag, it also has a timestamp key and a timestamp signature. Because the idea is like one of the big kind of attack that you have when you there is a paper. That I have a link inside, maybe it's later, no. Like one of the common attack is just replace a package, a new package with an old version of the same package. It means that if we are just looking for this, who signed that package or where it comes from the right repository and it's built from the right person. The real challenge is the version that you are downloading. You are asking for the download 231, but you are getting the 200 because the hacker knows that that version has a vulnerability. And they can use that vulnerability to compromise your application or your system. It means that it's not just inject a completely different code, but you are downloading just the whole version. It means that it seems quite like the same code, but there is something that you don't know about. And the timestamp and snapshot are made for this reason, because every version is signed in a different way, and you can, the client is checking if the version that is taking is the version signed by the user, by the build engineer. All this framework has different implementation. If you go to Docker Notary, Notary is the project that contains a lot of security features by Docker. A lot of stuff using in SwarmKit that I'm going to show you later come from this repository, but it's also implementation of the Tuff framework. As I said before, it's a framework. If you are already a good use case and you feel that this kind of how you update software needs some security, you can have a look about how it works and maybe use it without Docker. Let's move over and let's speak about orchestration. Container Docker take with itself a lot of new kind of concept. Orchestration is one of them. How I'm going to ship my containers in a safe way in my production environment over all my nodes. As I said before, how you design the topology of your network and of your cluster is one good topic to think about. As I usually like to design a real simple infrastructure is in this way. You have a pool of servers that are in the public network, and that kind of servers are reachable by outside. All the other stuff are in your private network, and you have some secure link between them. But the idea is that you are not running container everywhere, but you can use label on Docker to specify that my containers can run only in the private nodes. Every time that you start a Docker daemon, you can specify, you use that command. I don't know if you know about it. When you do sudo service docker start, you are running this container. There's this command in some way. You can extend it and add labels. Labels are key value stored. Has this, we spoke before about the build kind of label. These are other labels, but they work in the same way. They are just key value store, and you can use constraints to say, Docker run this container only in the server that contain the label public. And you can join more of them and make some complexity. But the idea is that label is the way that we have to teach at the scheduler where to put our containers. And it's also a good way to split our networking and our nodes between public and private. Another feature, and I come back to the concept of secure by default. This is something that you have with Docker Swarm and you cannot disable. Every time that you start a Docker Swarm cluster, you have a certificate authority that it's in every master. Okay, let's keep it quiet. And Docker Swarm is the cloud feature embedded in Docker. When you download Docker from 1.13, you have this kind of feature that is called Docker Swarm. You can do Docker Swarm init in one server and Docker Swarm join, and you are creating a cluster of Docker daemon. And every kind of manager, there are two kinds of nodes, master and manager and worker. The manager are the top three, and they have a certificate authority that sign all the other nodes. The idea is that is mutual TLS. It means that every node has a signature, and you can, in this way, you can say, okay, this node comes from my certification authority, and the identity is trusted. Because without this kind of configuration, this kind of feature, a bad node can join the cluster because you are not able to understand this node is able to join or not, or it's a fake node that is just going to create trouble. This is what mutual TLS is inside Docker for, because you can, every node has a signature and you can verify if it's compliant or not with your cluster. Another feature that you need when you start to work with container is how you distribute your secret. Every application has secret, credential, API keys, database configuration that you need to keep in a safe place. It's not safe put them into the image during the build. That's not safe because everyone that has that image can read at the file. That's not a good way to store secret. A feature that Docker has and also Kubernetes has is the distributed secret. It's embedded in Docker Swarm and it works pretty easy. You can, let's say that you have a file that is called, that contains username root and password root, super secure, and it is in secret test JSON. You can run Docker secret, create the name of the secret and the file that you are having. After that, you can remove that file. And the secret is encrypted into the master node. What you can do when you create a service is you can specify the secret name, and the secret is going to be mounted in run secret myapp. It only supports, Docker Swarm at the moment only support file security. It's not working with the environment variable. If you have a secret and environment variable right now, it's not something that they are supporting. In first, because they are easy to leak. If you think about all the monitoring tools that you are using, all the agents, they can take the environment variable if they need them, because they are shared in your environment. It's a decision. It's a design decision that they took to, force a best practice, or what they think is a best practice. You can use other tools if you are not using Docker Swarm, but you have a distributed system, or you are using container without Docker Swarm enabled. There are other kind of tools like this. The most famous one is the HashiCorp Vault. It's designed to store secret, and you can use it. And there is more than one plugin to make something like this with Vault. Another security feature that it's free and you can use is the encrypted overlay network. You can just use the option encrypted when you create your network, and all the traffic into the network is going to be encrypted. It's not made like this by default, because there are some degradation in terms of performance, because you need to encrypt and decrypt all the network, all the traffic that is moving inside your containers and inside the network that you created. It means that it's not like something that maybe you are happy to pay. But if you are some strong service that need to be run in a most secret network, you have this option free to use. This is a new feature that comes in Swarm mode. When you enable Swarm, you can specify not just the advertised address. As before, only the advertised address was specified. And the idea is the advertised address is the network interface that Docker is using to communicate with the outside and between containers. You can specify not just the advertised address, but also the data patch address now. And it means that you can use two different interface network, one for the advertised, and for advertised, I mean all the traffic that Swarm is generating to keep itself alive. Docker Swarm is not just running your containers, it's also trying to understand if it's alive. It means that it's using I don't remember the protocol, distributed protocol, Raft, thank you. It's using Raft to understand if the cluster is alive. And all this traffic is going through the advertised address, and all the other traffic, I mean all the traffic that your container are generating, is going through the data path address. This is a double win. It means that because you can have two different interfaces with different security policy and configuration, but also it's a good scalability solution, because now, previously all the package and all the traffic was going through the same network interface. Now you can split them and have different configuration. We are almost gone, almost over. The beer is coming, I can see. Immutability is another idea. It's another good, like for me, matters about security, because every container is unique and nobody is able to modify your container. Every time that you deploy a new code, you are removing your container and you are replacing your old container with a new container. You are not updating the container itself. That's what immutability means. And there are a lot of goals behind this. A good point about immutability is making easy the deploy and the rollback. But from a security point of view, it's really good because it opens a new room that is the post-analysis. You can run post-analysis. And this is a really simple idea, but if your let's say that you are running WordPress, and I'm not using this example because it's easy to have injection with WordPress, and just because it's famous. If you are running WordPress and somebody is injecting code inside it, you can take out the container, and you can use Docker diff to understand how your containers changed. And Docker diff is using this kind of output, is going to say to you which file are changed, or which directory. In my case, in my example, I take the Alpine image, and I wrote 2 files. One is index, and one is spy. The output is pretty simple. The var directory changed because I created a new www with 2 new files. It means that if you think that your container is compromised by the code injection, you can analyze your container in this way. Now, containers are not magic. They are not making bad code good, looking good. If your code is good, is bad, stay bad. If your code is good, stay good. There are new layers, security layers. All this stuff that we spoke today are layers that you can use and to make your environment more secure, but it's not going to fix your code. You still need to fix your code. Write good code. Thanks.